So all of the electron configurations that we have done to this point have been in the ground state. So don't overthink it too much. Anything that you have seen and would recognize as like the proper electron configuration is a ground state electron configuration. And that's because we learned the most stable, lowest energy arrangement of the electrons in the atom. So the electrons are in the correct order of orbitals, meaning they started at energy level 1s and then went to 2s and then 2p and then 3s and 3p and so on. And that follows the rule of filling up the lower energy levels before moving on to higher ones. The excited state is when an atom gains energy and then electrons jump into higher energy levels. So basically, in the excited state, electrons are hanging out where they're not actually supposed to be. So 3 ways to excite electrons. These are not like all of the ways that you can excite them, but these are 3 common ones. So in our lab on Wednesday, or next time I see you, what we will use to excite electrons, meaning to put energy into these atoms, is thermal energy. So we use thermal energy through fire. We'll use the Bunsen burners for that. Another way to excite electrons is using electrical energy. And then a third way that you can excite electrons is through mechanical energy. There are definitely other ways to excite electrons, but these are 3 like really common ones that we're going to talk more about. So when we excite them, this means that you are taking some type of energy and the electrons will absorb energy from one of those sources. And so what happens when the electrons absorb energy, so if energy is like going into this system, this electron that is normally, we'll say at energy level 1, would get excited and jump up to energy level 3 because it now has more energy than it had in its natural ground state. After an electron gets excited, so after it gets excited and is hanging out in this third state, so we have an excited electron here, eventually that electron has to go back down to its ground state, and when it goes down to the ground state, it has energy to expend. It has energy to give off, energy to release. And so the way that we see that is oftentimes through light, so that's why it has this light, and there's super light printed on here, but you can kind of see this like little arrow. Do you see these? You see what I'm talking about? So these little squiggly arrow lines, that means that light is being released from the electron as it falls from the excited state back down to its ground state. So energy in means the electron is using that energy to jump up to a higher energy level. And then once it has already been excited and falls back down to the ground state, it has energy to give off, energy to release, and we oftentimes see that energy as light. Make sense? A question that students get wrong all the time is, at what point during this process do we see light? So if you had to describe that, if you are seeing light, does that mean that electrons are gaining energy and getting excited, or does that mean that they're falling back down from their excited state? Falling back down from their excited state. Perfect. So, wouldn't that be something? I didn't hear that last part. What did you say? Sure. We could say that. Alright, so the recap here says electrons go from ground to excited. This means that they have absorbed energy. And then electrons go from excited to ground. So So that means they have already been excited. They're falling back down. This is when a photon or light is emitted. So they are releasing energy. So a photon is basically just like a little packet of light. So this question is like the ones that y'all were asking about when you got to class that were on your homework. It says, identify the following atoms and describe their state. Are they ground or excited? So now, my warning is that you cannot use just this last little piece to identify the element anymore, because if I look at 4p3, who does that say this is? What element? (4p3) is arsenic. Okay, so if it's arsenic, how many electrons does arsenic have? 33. If I have 33 electrons, I know that this is an atom, which means that it's neutral, which means that my number of protons equals my number of electrons. So, if it truly is arsenic, then it should have 33 electrons, because my atomic number is 33. And I have 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, 19, 29, what's that? 32. So this does have 32 electrons. What? It would be excited, and who is it? So what element has 32 electrons? Germanium, Ge. Yes, alright. Shh. She asked a really good question. She said we would base... Can you ask that again? Yes, if it says that it is an atom, you would base what element it actually is on how many electrons are accounted for. And so double check, triple check that you've counted right. And then the other thing that you should find is that something doesn't look right in the electron configuration. So if you're looking through this, you know that any S sublevel should have 2 electrons, any P sublevel should have 6 electrons, any D sublevel should have 10, and if I'm looking at this, that 4s1 automatically stands out to me, and I see, okay, 4s1 is not a thing, because if I only have 1 electron in my 4s, if I only have 1 electron in my 4s sublevel, then I would have never moved on to 3d10, so there should have been a second electron in that sublevel. And if we're trying to figure out where it went, well, it becomes evident that it ended up in my 4p sublevel, because germanium is really 4p2, so that third electron that's in my 4p sublevel came from here. So it is an excited germanium atom. So then if I'm looking at letter B, I have 2, 4, 10, 12, 18, 20, 30, 35. 35 electrons. And who has 35 electrons? Bromine. Is bromine in 4p5? Yes. And then just to double and triple quadruple check, does everything look right till I get to that point? The S sublevel is full, that's full. That's full, 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 full. So it goes in the correct order of lowest energy to higher energy, so that would make this a ground state. Basically, if it is a correct electron configuration, it's in its ground state. And then letter C. How many total electrons is this? 46. Who's 46 electrons? Palladium, good. PD. That's okay. It is quite possible that I pronounced them wrong. I just sound it out and read it. Maybe someone calls it palladium. That's okay. I don't actually know. So, is there anything out of place here? Does 4d8 identify palladium? Yes. And nothing that comes before that is out of place, so I would say that this is in the ground state. Good?